Hey guys, how's it going? Alex Smith here. I'm the chassis team lead for BYU Racing in the 2025 season. I'm a senior in mechanical engineering, and I'm just going to be walking us through a little bit of the documentation that the chassis team has done in preparing and setting a precedent for the new teams that will be coming through as BYU Racing, and just kind of highlighting how we are going to go about doing it. So let's go ahead and jump in. I'll share my screen so you guys can see what we're talking about. Alrighty. So when you're getting into Notion, I would start here in the engineering home. So if you found this video, that means you already know that the knowledge library exists. We've got resources for each subteam, and then you've probably found this documentation tutorial on the templates page. So this is where the video that you're watching is linked right here. There's another one. I highly recommend watching it. I might be a little biased, but I think it's a good video. And then there's this template that I've made that kind of highlights the little format for an IMRAD paper that we're using. We're spoofing on it a little bit for our purposes. And yeah, after you've done that, go to your team dashboard. I'm going to chassis, that's my wheelhouse. If we come down here, there's this full chassis system, and then we're going to our system design document. So each sub team should have this. There should be one for aero, for ergo, pedals and brakes, you name it. And this is just saying this is an overview essentially. So when you go to competition, this is one reason why we do documentation. One is to make sure that we have something to pull from. So at competition, the design judges will have an event with us where we can score points based on how well we did in designing our car. And granted, while it is a little subjective, being able to back up why you made your design the way you did and how you did it with some concrete evidence of some previous forethought is pretty important. So I would suggest making sure this is really filled out well, but I'll walk through each element of this. Again, there's some basics here, a little overview as well you can go check out. So if something I'm saying is not quite making sense, hopefully it's explained there. But this is how we've done it. So these first two boxes are related. The system requirements come from having made our sorry, what's it called? A requirements matrix. There we go. That's the word. And this is where we're defining, what do we want the car to do? What do we want components to do? So we're saying the chassis protects the driver, the chassis is rule compliant, lightweight, affordable, etc. And then for each of these requirements, one or more of these performance targets are tied to that. So, for example, for the chassis being lightweight, we have the weight here. But torsional stiffness could be tied to that. So we have these are quantifiable amounts of some kind of metric that helps us determine whether or not our car is meeting our design requirements. So this is a crucial part. This is what we can say when we get to the design competition. They say, why did you make it this way? Well, for example, the frame has this torsional stiffness of 1700 Newton meters per degree, and that is some amount of torsional stiffness that relates to what we have here. We can discuss whether or not we met it, how that ties into our original design requirements, how it meets the purpose at its core. So that's why these are really important. I'll take a step back here for a second. Another reason why we do documentation, um, besides setting the precedent and making sure that we have something to go off of for our design review at the competition, is so that we're remembered. A lot of ways that we can make sure that we make an impact on the team comes from setting a precedent and writing down what we're doing and explaining ourselves. Because if we make something and then leave it there for the team to figure out how they did it, then that's not very helpful. And being able to decide how we can move forward and iterate better comes from having something to go off of in the future. So, if you want to be remembered as a member of the team and leave your mark, then please do good on documentation. Okay, I'll get off my soapbox now. So, getting back to the document here, we have our concepts considered, and this might look different for every team. So, maybe brake rotors, here is just as a silly example, instead of space frame or monocoque, maybe you're looking at round versus oval or square shaped ones. Maybe you're looking at different suspension geometries. That's all what you're doing here in Concepts Considered. This is a really early in the design stage. Well, it's not even in the design stage. This is before that, deciding what concept you're going to design. And then this box is tied to these two, where you're saying, okay, these are the pros and cons of each of these options. So for the tube frame, we have all of our pros here and all of our cons, and then we summarize it a little bit. And then in the next page, we say, okay, this is the concept we've landed on. This is what we're going forward with, and this is why, and these are reasons why it might not be ideal, but we're still moving forward with it. So this is a lot of writing up until this point, and it you might be wondering now, it's 2025, how much of this are we actually writing versus throwing into some kind of language model to write for us? And I would say if you're going to use that, then you should do that, but do it wisely in the sense that you're writing stuff down, word vomit whatever you need into the model, and make sure you read what you're getting out of it so it doesn't lose any of the important things that you're putting into it. Because it's a great tool. It can speed up this process a lot, but sometimes it doesn't capture the full idea or leaves out key information. It would stink to go to the design competition and say, oh yeah, we chose a tube frame chassis and you have two or three pros here, but then he brings up one of these cons that you haven't addressed or that you have addressed, but you just didn't get back from ChatGPT or some other source. And then you're left grasping at straws for why you decided on a concept when you totally know the reason why, you just can't remember it in the moment. So after we've done the concept selection here, we're looking into the design stage. And so instead of including a bunch of different links and a bunch of different pictures and screenshots of the CAD, we just linked our Onshape page because if you want to get more details, you can go ahead and go look at all of the modeling we're doing. That's a lot of nitty-gritty CAD work that the design judges don't necessarily need to know. And if someone's looking at your work after, they can go and find that work in Onshape after you're gone. So this is what we have. This is all we have for CAD design. And if you are curious, go check out what we did there. I will probably do another video on how we go about doing our design, just kind of as a rule of thumb for future years. But that aside, the something that's very tied into the CAD portion of doing this page is FEA models. So FEA, if you don't already know, stands for finite element analysis. And this is a really important part of the design process because you can design some crazy, awesome suspension upright, but if you don't know how it's going to behave under stress or how it's going to deform and or whether it's manufacturable, then you probably ought to take a step back and make sure that you're doing CAD a little better or just considering something different. And a lot of ways that you get some feedback on that is by doing this FEA. So the way that we decide, at least the chassis team has decided on how to set up our finite element analysis, which is outlined in this document, and that's talked about in my next video, is we step back and look at ways other universities were doing this. This is part of concept development. We said, okay, we need to be doing these tests. So how are we going to perform it and how do other teams do it? And this is our document on that. So you can see that even though this document is designed to be really more of an overview of the whole system, we're putting things in here, additional resources if we need to go deeper, if others need to go and find more information. So be sure to put as much as you can in, at least in the form of links, so that people can follow your thought process. And then once we've done FEA, as we're walking through this design process, developing this product, then we move to manufacturing. And so if we don't have steps on how to make something, then we are left kind of looking around online and trying to find other ways to do it. But if we have something written down for what we did last year, then we know we can do something and improve on that and make it better. So that's kind of what we did. We have drawings here from our Onshape. Again, it's linked right there. But then what we did, because our subsystem is a system that links everything else together, being the frame. It's just one big metal structure. We just have a welding plan. And so this is basically instructions for how to put it all together once we get the material. But I'd suggest putting something similar. So going back to the suspension upright, if you're going to make this out of billet aluminum, then you better have some steps on how you're going to turn it on the lathe or mill it on, just a regular old mill, or maybe you're going to CNC it. And if you're going to do that, then you want to put in information on another linked page on who you contacted at the prototyping lab, what feedback they gave you on your design, why you changed it, how that affected other aspects of your design. See, being as detailed as you can in these other pages and leaving an overview here is the way we want to move forward so that we have all the information, but we don't necessarily need it all in the same place. So, once you've built it and you start putting things on the car, you're going to want to test what you have before you put on the car. So, this is a place where you link pages for validation for your design because FEA is only so good. Your hand calculations and math are probably idealized and they don't behave as perfect as you think they would in real life. So that's where you're linking pages to the frame validation, or maybe you're verifying stopping distance on your pedals and brake system. Maybe you're talking about how the drivers felt when testing out the different foam inserts for your seat. There's all of this validation you can be doing, and the more that you put in here, the less the judges can pick you apart for not having done it. And so, speaking from experience, we know that not having done testing doesn't look great, especially in the engineering world when testing is kind of 90% of what you're doing after you've made something and you're perfecting it and making it better and looking for different ways to improve. So we've included all of our different links to different tests. So and different components here that make up the chassis. Granted, there's not very many, but we have all this documentation here that we can go back and point to when we get to the competition and say, look, we actually did do some validation here. Maybe it's not comprehensive and the judges can point that out, but at least we've done something. And so having that in there is really, really helpful. When you've done that and you've got all those linked, throw some pictures in there of what your assembly looks like. Because ours is so big and it's pretty much one big piece, we have a couple pictures here. We'll probably put in some more so that we can get the floor closeout and firewall pictured in there. But most of that you might want to consider putting in a Google Photos linked album because those can be accessed by anybody with the link. And that's a lot easier than just throwing a lot of pictures in Notion because sometimes that takes a while. So there you go. There's some pictures there. I think it's pretty cool. But the last two things here are design features that you want to highlight. This description here and here are pretty straightforward, but these are things that maybe are unique to your design. So, for example, in this rear side of the car, you can see that we've got some parts here that are very square. That was a feature that we designed intentionally so that we could weld the frame faster by having these two squares on different side of the table, have two welders going on at the same time. So that's just a key feature of our design. There's also this rear box here that was a kind of a headache for us in designing, and that's something that needed a lot of testing and FEA, and that we hopefully will get some more validation of when we do physical testing in when the car is driving. But those are just things to consider for putting things in here. So maybe design features, maybe for the upright, this year's was 1 pound in weight. So highlighting how you're able to get to that weight is good. Or if you're designing the pedals and brake system, why you chose a certain feature of the design. Maybe you were able to make it more light and you highlight a feature of that design that allowed you to do that. So those are just some key things that you might put in here, but that's kind of the overall system design document. We're hopefully setting a precedent here for everybody. We want to make sure that our knowledge gets passed down and gets built on, and so that we can end up being, competition winners. We don't want to stay in the back of the pack for very long. The goal is always to improve and learn, And so this is the foundation of how we do that. I hope you enjoyed watching. Check out the other videos that are coming along. And yeah, stay on the team. See ya.